Hello, this is part two of my series looking at the Atari ST motherboard and keyboard that I got yesterday. Where if in the previous video it was shown that although the motherboard seemingly works fine under diagram, the keyboard just doesn't work under TOS. Now, I've posted on the Exos forum, and someone suggested that maybe it was an interrupt issue because they thought that the diagram didn't actually use interrupts, but the ROM does for the keyboard. Now I did go away and do a quick check to see what happened on the Atari ST motherboard, depending on whether you're on in diagram or not, and interesting results, which I'll show you now. Right, I've got the system set up with the diagram installed. The two chips that are used by the system for the keyboard and for the MIDI are over here. They are 6850 chips, basically just a general I/O. They're serial chips. They're controlled by the 68901 multi-function peripheral device. Now, each of these have a shared IRQ line, and it's on pin 7. I'll show you the schematic shortly, but for the time being, let's just do a check at what actually happens when you power the system up. So 1, 2, 3, 4, 5, 6, 7. That's the IRQ, and I'll switch on. And as you can see, the IRQ line goes high, and then if I reset again, goes low. Let's go to there, and should be able to see the pulse then. As you can see, it just went low for a brief period and then went high again. And whenever you press a key, it goes down low. So I'll try that. I'll take the diagram out and switch on from using the main ROMs. Goes high and then immediately goes low and stays low. That means the interrupt is being held down all the time. This means that the system cannot actually see any interrupts from either of those chips. Another interesting thing is if I again boot with the diagram, as you can see, it goes there. I'll go blindly go to the MIDI, tries to use the MIDI port, and as you can see, there's getting an interrupt from the MIDI 6850, and eventually it will fail. But the interrupt will never go away. So I can hit the keyboard, and you can possibly see now and again you get a second pulse, because that's from the keyboard 6850. I'll swap out the boards and see what happens with the reference system. So here we are with the reference system, again with the diagram installed. I'll switch on. The IRQ line goes up, Goes low, we'll hit the M, and as you can see, that immediately quits, and the IRQ line comes back up high again, and every time I press the key, I just get a single pulse. So it sounds like the MIDI 6850 may be faulty. So let's just switch over to using TOS and see what happens now. Goes high, it goes low, back up high again. It's trying to read the floppy at the moment. If I press keyboard keys, as you can see, that's doing the same thing. Eventually it will time out. Let's put the floppy in there. Three, 4, 5, 6, 7. As you can see, it's high most of the time. So as you can see, there's an issue on the IRQ line for those 6850s. So let's go over and have a look at the schematic to see what that shows us. So let's look at the schematic. We have the two ACIA chips, the 6850s. One does the MIDI ports and the other does the keyboard ports. Both of them have pin 7 IRQ out joined together, and they go up here to the 68901 up to pin 26, and the line is just pulled up by a 1K resistor. So really the only thing that can output to this line are the two ACIAs, because although the 68901 can use these as a general purpose input output, they would need to be configured as such. Otherwise, these just act as interrupt sense lines. The first thing I need to do is unclip the shielding from the bottom, and that's often quite tricky. Oh, that's bent over. Right, you can see these are the two chips we'll need to remove. I think that's the other chip there. I won't touch that for the time being. Yes, that's the MFP. The MFP is that chip there. I'll go and get the Hakko desoldering iron out, and then I can make a start. Before I do the desoldering though, I'll first of all put some fresh solder onto these chips. Just gotta wait for the soldering iron to heat up first. Right. Doesn't seem to be flowing very well today. Let's get some of this chip quick. Flux on there because it's not flowing at all. Come on, glue. Right, let's see if this will be sorted okay. Oh, it's quite a struggle. That's right. Are these free yet? Nope. Right. Switch over to the hot air station. starting to lift. There we go, one. I think I missed a pin there. That's better. Try not to put the lead of the hot air onto the Hakko locked cable. Okay. Right, the all seem fine. So that there, this was the keyboard one. So let's mark it. Okay. Right. You look quite clean. Let's see if I've got the correct size socket. So that's 3, 6, 9, 12, so 24 pin. Of course, I haven't got a 24 pin socket. However, what I can do, hopefully, is cut down a 28 pin socket to fit in there like that. These capacitors are a bit of a pain. Let's see what I can do. Cut the pins off. See what fit like that. Make it well enough. I'm going to have to cut that away. It's webbing out. Yeah. Stronger. Just cut that away a bit. What I do. If I do the other one the same. I'll do the wrong end. Throw that wire away. Right, I need the non-dimpled end. Oh, wrong side. Doesn't matter. Wait a bit more. Right, that'll do. Got blue tack to hold the sockets down for soldering. I'll see. Wait while the soldering iron warms up. I can put the flux away. And I don't need the Hako anymore. Do the corner ones. The flow onto the circuit board today. It's got stubborn ground plane. Right, that should be all the soldering done. Right. Oops. There goes the camera. Right, that's okay. So if I put the first of all, I keep on forgetting to take the blue tack off when I'm doing soldering. So I take that off and just put the keyboard. Let's just clean these pins up a bit. Legs up. It's a bit tarnished at the end. I should be alright. Right, and let's get them the right way around. Pin one over that side. Right. Let's get the power supply in and we can test it. First of all, I'm going to use the diagnostic rod and it's got tangled. Oh, it helped to have the keyboard, didn't it? That's on pin 7 again. Let's change this. Tangled. Actually, I can use this socket. 1, 2, 3, 4, 5, 6, 7. Let's see what happens. Oh, it helps to turn the light, power on. Nothing. Well, it helped to turn the power on, wouldn't it? 1, 2, 3, 4, 5, 6, 7. Nothing there. 1, 2, 3, 4, 5, 6, 7. Nothing. That's interesting. Okay, so okay. Let's check there. That's doing the same thing as it was on the toss. I've got the right the chips the right way around, haven't I? 1, 2, 3, 4, 5, 6, 7. Let's try on the toss. Goes up, then down, stays down. Okay, let's swap these over. Maybe I've got them swapped accidentally on the wrong place. I knew I should have mocked them while they were on the motherboard. Right. 1, 2, 3, 4, 5, 6, 7. Nope. Put the diagram back in. Staying up, but nothing's happening. Okay. Trying this one. One, 2, 3, 4, 5, 6, 7. Okay, that's working properly there. Try it without the ROM. And that's working. Okay. So if I switch over to the ST, we have a working keyboard. Obviously had the I've misread the sockets. So if we put this other 6850 back in, let's see what happens. No keyboard. So in the end, it was, there we go, one bad 6850 chip. I've got some more on order from eBay. So when the replacement arrives, I can just throw it onto this motherboard, and that should be a completely operational machine. I'm not sure when I'll do another video. It'll probably be when I've found something else that needs fixing. But in the meantime, well, I hope you enjoyed this video. And as everyone seems to say, hit subscribe button, like, bell, whatever you like. I'm not monetizing these videos, so it doesn't really matter. Anyway, goodbye.